Latitude Media, podcast at the frontier of climate technology.
I'm Shail Khan, and this is Catalyst.
It's a bloodbath out there. The Chinese market in particular, it's a bloodbath.
2024, it was the best of times for battery buyers. It was the worst of times for battery manufacturers.
Catalyst is brought to you by Energy Hub. Facing urgent load growth, it's time for utilities to rally behind VPPs as a solution to diverse grid challenges. Energy Hub helps utilities quickly scale VPPs to manage load growth, maximize the value of renewables, and deliver flexibility at every level of the grid. How do they do it? Energy Hub's software and services enable grid-aware VPP management across distributed resource classes through a best-in-class Edge DERMS platform. Accelerate a reliable, affordable, and decarbonized energy system today at energyhub.com. Artificial intelligence is one of the biggest stories in energy right now, from the AI-based solutions for the grid to the unprecedented load growth caused in part by the AI boom. On December 3rd in Washington, D.C., Latitude Media is bringing together a range of experts for Transition AI 2024, a one-day conference on the AI energy nexus. We'll have networking, panels, a workshop, and technical presentations, and our podcast listeners get a 10% discount off their tickets. Use the code LMPODS10 when you check out. Head on over to latitudemedia.com/events or click the link in the show notes to see the full agenda and register for Transition AI 2024.
I'm Shail Khan. I invest in revolutionary climate technologies at Energy Impact Partners. Welcome. All right, so talk to anyone in the battery world over the last few months, and I guarantee you at some point in the conversation, you're going to end up marveling together at just how cheap lithium-ion battery cells and packs coming from China have become. Bloomberg NEF put out a stat that I've heard cited like many times since then, a couple of months ago, that LFP battery cells in China on the spot market were selling for $53 a kilowatt hour. Just truly bananas cheap relative to what you would have expected even just a couple of years ago. So you combine that with recent announcements from companies like Northvolt in Europe struggling mightily and some delays or cancellations of new battery manufacturing capacity that was announced for the United States. And the obvious question becomes, can the West ever really compete? Or is it game over? That, of course, is a function of many things, not least of which are end markets, geopolitics, trade policy, and so on. But at a fundamental level, one question I've always had is, how much cheaper is it really to produce battery cells or packs in China, and why? The answers are actually sometimes a little bit less obvious than you might think, and they are vitally important to the future of batteries in the battery market. So, to discuss, I brought on James Frith. James used to lead energy storage research at Bloomberg NEF. Now he's on my side of the fence as a principal at Volta Energy Technologies, which is an investment firm focusing on the battery supply chain all the way up and down. Here's James. James, welcome.
Hey, Shail. Thanks for having me.
Let's talk about what the hell is going on in battery manufacturing world these days, or I guess the battery market in general. Can you just give me, let's start at the highest possible level. How would you characterize what is happening today in that space?
I think there's a couple of ways I could do it. I mean, the rawest way, and this is what I've heard from a number of kind of companies in China in particular, it's a bloodbath out there. The Chinese market in particular, it's a bloodbath. On the other side of things, if you're an environmentalist, you want to see the world electrified faster, we're in a fantastic position, right? We've got LFP prices from China down at kind of $50 per kilowatt hour, which is...
That's at the cell level, right?
That's at the cell level, yeah, exactly. That's the cell level. At the pack level, the rule of thumb is kind of 30% on top of that. So you're still kind of well below $100 per kilowatt hour. And that's just, to kind of put it into context. Back when I was at Bloomberg NEF, I used to run the battery price surveys. I think probably 2020 or 2021 when we were doing that, we'd kind of forecast out the numbers. And we're expecting that by 2030, 2035 or so, you could get down to kind of $50, $60 per kilowatt hour at the cell level. And we're there 5 years early. Now, there's a lot of kind of nuance going into that of why we're there. And part of that is the kind of bloodbath in China. But it's just crazy to think that we've got there so quickly. And these are prices that, I got a lot of flack for even kind of suggesting that we could get there in 2030, 2035, and yet here we are today. So kind of great for the battery industry, if you like, or the electric vehicle industry for consumers. Not so good if you're a battery manufacturer.
I want to talk about why that's happening. But first, I guess one question I always have when I see these numbers quoted is like, are those who is actually getting those prices, right? Like those are presumably spot prices. Is there a large spot market for LFP cells, for example, in China? And so it's like a decent chunk of them. Is that flowing through to actual battery prices at significant volume here? Or is it like a thinly traded spot market where most of the market exists under long-term contracts that are at higher prices anyway?
Yes, it's a great question. And, it's pretty thin spot market, if you like. If you think about the kind of bulk of battery demand is coming from the electric vehicle industry, and those are, those contracts are really kind of long-term contracts. Where you have more exposure to these kind of the spot market, if you like, or kind of shorter term kind of purchasing, is in the stationary storage market in particular. So in China, and again, kind of crazy numbers coming out of China in terms of stationary energy storage costs, not just at the kind of cell level, but at the system level. At a system level, kind of for a turnkey system, you're looking at something like $135 per kilowatt hour. So again, kind of crazy low, considering that 18 months ago, the average price of a cell was about $135 per kilowatt hour. Now you can get an entire storage system in China. But again, even those kind of spot markets in China, kind of getting to the $50 per kilowatt hour, it's low in China. Some people can access that. That's not a price that's necessarily going to be reflected if you're a stationary storage developer in Europe or the US. You're going to be paying higher than that, and you're not going to be as exposed to those spot markets. Also worth considering kind of what's the quality of the cell that you're getting. We hear more about kind of tier 2, tier 3 manufacturers or kind of B grade cells that are being sold at lower prices. Having said that, there's also kind of reports out there of CATL having some of their pricing structured down at that point. But again, not for kind of long-term bulk orders going into, let's say, the EV industry.
Yeah, so it's kind of a low watermark, right? It's like this is the lowest pricing that's available anywhere in the world, but everything else kind of flows from that. So it does tell you something. You also mentioned the other thing that I think folks outside the industry probably don't sufficiently appreciate, which is that when prices crash like that, it's the stationary storage sector. It's like grid energy storage that actually sees the benefit from that from a cost perspective fastest. And that's one interesting dynamic, whereas EVs, what you think of, which is still, EVs are still the majority of demand for lithium ion batteries, longer term contracts, new models, et cetera, it takes longer. Let's talk about why. So is it just a matter of overcapacity? Is it that we've talked before on this podcast, everybody's talked about a kind of slowdown in growth for EVs, basically everywhere outside of China. I mean, China doesn't seem to be slowing down at all. But is it that there was an overbuild of new capacity and then demand softened just enough that now the market is flooded, or is it more nuanced than that?
That's certainly a big part of it, but it's a little more nuanced than that. And again, kind of for kind of context, if you go back to even 2020, or for the last couple of years, in fact, there's always been a slight overbuild in manufacturing capacity, and demand kind of, takes a little while to catch up. So, and that does depress prices, and that's certainly kind of part of the story now. But I think you've also got a kind of confluence of factors. So you've got this oversupply in manufacturing capacity. You've got a softening in the electric vehicle market as well, which I think the kind of, as you say, the kind of signaling of that to the rest of the market is that demand isn't there, and therefore if you want to maintain market share or gain market share, you've got to kind of reduce your prices. But you've also got other factors like low commodity prices. So we've got lithium kind of not at an all-time low, but very, very depressed, below kind of $20,000 per metric ton. And you've also got another kind of factor, which is perhaps kind of less clear exactly how it plays into these low prices, but we can get into it in a minute. And that's that a lot of the companies in China and the supply chain, cell manufacturers and material providers had stockpiled material over the last couple of years, particularly when raw material prices were very high. And so they then have that material sitting on their books, and they want to kind of shift that and then resupply with low-cost materials because, who knows how long we're going to be in this low-cost environment for, right? You can look at some forecasts that say lithium prices are going to be depressed until 2028. On the other hand, you have some price reporting agencies that are telling us that we'll be in a kind of undersupply situation for lithium in the next couple of years, and you'll see prices kind of shoot back up. Whatever the truth is, today you've got low raw material prices. So if you have, the ability to kind of restock your capacity at this point, it makes sense to.
In some ways, it seems, and this is often true, it seems like companies are behaving exactly the opposite of how they should, right? If you were stockpiling lithium when lithium was 50,000, that was a bad idea. And if you're trying to get rid of all your lithium now when lithium is 20,000, that's also probably a bad idea. And yet that's what everyone does in these markets.
Yeah, exactly, right. And it's been a crazy market, the lithium market, the last couple of years. I think going up to kind of over $60,000 per metric ton a few years ago, and expectations that price was going to, or those high prices were going to hold for a number of years, or potentially kind of even go higher. So you exactly saw all this kind of stockpiling at relatively high prices, and then we've had this sudden crash, and it's kind of thrown the industry. And I think material suppliers, cell manufacturers, aren't sure what strategy they should take at this point.
Catalyst is brought to you by Energy Hub. Energy Hub unlocks the power of VPPs to deliver flexibility to the grid. How do they do it? By enrolling DERs in customer-centric flexibility programs and using AI-driven optimizations across devices to shape desired load profiles. Energy Hub has more gigawatts under management than any other edge DERMS on the market, and they have a proven track record of building high-performing VPPs in record time. Working with more than 70 utility clients across North America, Energy Hub delivers reliable flexibility at every level of the grid. Click the link in the show notes to learn more, or go to energyhub.com. Where are you going to be on December 3rd? I know where I'm going to be. I'm going to be in Washington, D.C. at Transition AI 2024. That's when Latitude Media is offering the chance to hear from experts on the front lines of AI deployment in the energy sector. Transition AI 2024 is our one-day in-person event, again in Washington, D.C. It addresses both sides of the AI energy nexus, the challenges AI energy demand poses for the grid, and the wide opportunities to help climate solutions. This is our third event, and we brought together a really great lineup for this year. It includes Meta's former Director of Energy Strategy, Peter Fried, DOE's Chief AI Officer, Helena Fu, Paige Crahan, who heads up Tapestry, Google X's moonshot for the grid, and AES Chief Product Officer, Chris Shelton, plus many more. And our podcast listeners get a 10% discount. Use the code LMPODS10, that's Latitude Media, LMPODS10, when you check out. See the full agenda and register today at latitudemedia.com/events, or just click the link in the show notes. I will be there. I hope to see you there. Transition AI 2024.
Okay, so sort of two high-level questions then. One is like, is this pricing that we're seeing in the market right now, is this sustainable? Like, is this the new normal, right? Like, battery prices have been on a long-term downward trajectory, and everyone has expected that to be true and expects that to continue to be true to some extent. So is this just kind of where we are today, and then now we're going to keep marching down in price from here? Or is it this short-term phenomenon driven by everything that we just talked about, where like, okay, people are going to, run out of stockpiles, lithium prices are going to recover, this oversupply, there's going to be a shakeout in the market probably. We've seen this before, right? Bunch of tier 2 and tier 3 manufacturers in China in particular are going to disappear. And actually what we should be expecting is battery prices to increase at some point in the near future. Who knows if that's in 6 months or 6 years, before they continue their inexorable decline from there. Obviously, you don't have a crystal ball, but just help me think through the dynamics of what could cause one of either of those scenarios to be true.
So yes, and I would love to say that this is a new normal and that we're going to have these prices, going forward and kind of decreasing from here. But I think, unfortunately, we're probably going to see prices increasing at, moderately in the next kind of year or so, I would say, or kind of, let's say 2 years out, we'll probably see higher prices than we're at today. But I don't think like in 2022, when we saw kind of average lithium-ion battery prices rise for the first time, I think we're not going to see the average price rise particularly, but I think what we'll probably see is those kind of lowest prices that we're hearing reported in the market, that we just discussed, that are kind of perhaps not representative of long-term contract pricing. We'll probably see those prices increasing, but in general, the kind of average price of batteries is going to continue to come down. But I think, getting the big drop in prices that we've just seen because of those kind of confluence of factors that we discussed, I don't think we're going to kind of see that again necessarily. And I think the reduction in prices is going to be driven by fundamentals. So improvements to kind of manufacturing efficiency, falling capex, increased automation, kind of playing into manufacturing efficiency, changes to kind of cell design and pack design as well. I think that's something that people kind of often underappreciate in the impact that that's had on falling prices kind of prior to this point, let's say. And again, kind of changes to cell chemistry, tend to make a difference and have over the last decade been a big factor in kind of reducing prices. And I think that will kind of continue in the next, for the rest of this decade at least. There'll be some new cathode chemistries introduced. LMFP is one that, there's a lot of interest in at the moment. There are some kind of technical challenges that still need to be overcome. But there you have a raw material price that is kind of similar to LFP, but with a higher capacity. So when you put that into a cell on a per kilowatt hour basis, you're reducing the cost. And you've also got kind of changes coming on the anode side of things as well. So again, people are probably aware that the biggest changes to chemistry that we've seen in the lithium-ion battery industry have come from changes to the cathode material, going from NMC 111 through to NMC 811, reducing the kind of content of expensive cobalt and substituting it with nickel. And we haven't really had any changes on the anode side. It's been graphite. Maybe you're playing with your synthetic to natural graphite ratio to kind of balance cost and performance. But over the next few years, we're going to see the increasing kind of adoption of silicon materials. And again, some silicon materials, not all, but some silicon materials will give you a cost advantage over graphite. So on a per kilowatt hour basis, you'll have a cheaper anode material in there, which again kind of will have benefits, for the cell and for the pack as well.
This is a tangent, but why is it that we've seen so much innovation, so much change on the cathode side and so little on the anode side historically? Is it just a technically more difficult challenge to replace graphite in the anode? Or is it that graphite is like, we're starting from a better benchmark? Graphite is just like better as a starting anode material than NMC was for the cathode side? Like, why is it?
It's a little bit of both. So I think that there have been challenges in introducing new kind of anode chemistries. In particular, silicon is as I say, the kind of thing that everyone's interested in. The issue with silicon is that you get the very high capacity, but the cycle life takes a hit. So in order to increase the cycle life to the point where you can actually use it commercially, there's had to be a lot of kind of innovation and kind of engineering challenges to overcome, particularly related to swelling. So we've got companies now, Volta's invested in 1D Battery Science over in Palo Alto. They've overcome the issues around kind of cycle life using nanowires. You've got Group 14 and Sila up in Moses Lake, both of whom encapsulate the silicon to try and kind of reduce cracking and issues related to cycle life. So there's been a lot of innovation there that's got us to this point. But on the cost perspective, graphite's a really cheap material and it's hard to beat that. And that's why, when I talk about silicon potentially reducing the kind of cost further, it depends on the silicon solution you're using. You've got to have a silicon material that is inherently lower cost than graphite. And some people might adopt higher cost silicon materials for kind of particular performance reasons. But actually for the mass market, if you want to adopt silicon and you want to reduce costs, you've got to have a silicon material that has that kind of cost advantage built in.
Okay, so back to the main point. It's funny you mentioned, I asked whether this was sort of the new normal or ephemeral, and you said, I'd love it to be the new normal. It's an interesting, this is always true in these markets, right? On one hand, oh my God, battery prices are so cheap. look at what that's going to unlock in terms of EV adoption, in terms of grid storage, et cetera. So like from a market adoption perspective, incredible. On the other hand, I think of it as being sort of unfortunate timing because we were right in the midst of what seemed like, and maybe seems like, this is sort of the topic for us to discuss, a manufacturing revolution in battery world. I mean, everything from raw materials up through batteries themselves in the West, right? In Europe, we had players like Northvolt that were starting to scale. In the US, we had the IRA pass, which has all sorts of carrots for domestic manufacturing in the battery supply chain. And all these project announcements, everything. But it's like the timing couldn't be worse in some ways because everything was nearing or had just reached FID. Everything is supposed to be getting constructed. And then here we go. Now we're going to be able to domestically supply our own batteries and battery materials. And then prices crash through the floor. And so I guess two questions there that I want to delve into. One is, what do we think that means for this raft of potential battery manufacturing in the West? And second is, I guess I want to talk at a more fundamental level about what drives the difference in cost and to some extent price between battery manufacturing in China and in the West. It's to some degree intuitive to people, but I actually think what you might assume are the big cost drivers are probably not the obvious ones. So let's start with the cost differences, and then we can round back to like, what does this mean for the future of Western battery manufacturing? Just highest level, talk to me about like, if I'm building a gigafactory for LFP or, standard run-of-the-mill battery manufacturing facility, and I'm doing it either in Europe or the US on one hand, or if I'm doing it in China on the other hand, like what drives the difference I'm going to see in my cost in either case?
So yeah, this is an interesting topic, and I think, as you say, some of the factors are what you would expect, but perhaps the scale of the impact of those factors is less than you would expect it to be. So, and I kind of split it into OpEx and CapEx. So if we're starting with OpEx, and I'm going to start with OpEx, just because, and we'll get to CapEx in a minute. In my opinion, it has a bigger impact. The CapEx numbers can vary quite significantly, but when you think about it on the kind of number of millions or billions of cells that you're producing kind of each year, you're amortizing that kind of CapEx. It's not as significant, but we'll come back to that in a minute. So if you're looking at the kind of the differences, the kind of key drivers of difference on the OpEx side between any country in the world, China and the US or wherever, you're really thinking about cost of labor, cost of power, kind of other utilities, so water in particular. There's a lot of water used in some processes. Environmental costs, so what have you got to do to meet kind of local environmental regulations, and that obviously kind of impacts on CapEx as well. But those are really the kind of the things that I'd be thinking about: labor, power, utilities, environmental costs. And there is a difference. It's kind of clear that labor costs are going to be kind of cheaper in China than they are in the US. Interestingly, actually, kind of power, depending on what state you're in and kind of what part of China you're in, power is not that different, and so it doesn't kind of differentiate things as much. And even on the labor side of things, if you go back kind of 5 years, 10 years even, battery manufacturing was far more labor intensive. But what we've seen over the last 10 years or so is that processes are becoming increasingly automated. So the cost of labor doesn't have as big a kind of differentiating factor on the cost of producing in China as it does in the US. The other kind of areas, so utilities that I mentioned and environmental kind of impact, there is a little bit more of an impact there, particularly on the environmental side of things. Some of the regulations in China are more lax than you'd find in the US. But again, actually, having said that, if you're a large-scale manufacturer like CATL, producing cells in China that you're selling to the rest of the world, quite often you're meeting the environmental kind of targets set by your customers. So although you might not have to do it for local regulations, you still got some of those kind of costs in there. But again, if we kind of take those factors on the OpEx side and we kind of look at that as a percentage of the kind of total cell manufacturing, and again, using the example of LFP, the operational costs account for somewhere around kind of 20% of the total cost of a cell. You've then got roughly 10%, which is related to the kind of capex, so equipment and plant capex. And then the rest of what you're looking at, kind of 70% or so, is the material costs, whether that's kind of anode, cathode, electrolyte, etc. So changing those kind of OPEX numbers that we talked about, it has an impact, but not so significantly. And I plugged some numbers earlier into the model from Bloomberg NEF. And looking at the difference between kind of the US and China. So for a LFP cell produced in China, 35 gigawatt hour facility, you're looking at around kind of $68 per kilowatt hour. So this isn't kind of optimized for these super low prices that we're seeing today, but assumes a kind of LFP material costs of about $5 per kilowatt hour. You compare that to manufacturing in the US, and so again, the only things that we're really changing here are those OPEX numbers and CAPEX, again, which we'll come on to in a moment. But the cost of manufacturing in the US is about $75 per kilowatt hour. So it's only 8% higher if we're changing those kind of common variables that you would be thinking about if you're moving from China to the US. So it's not a huge difference, really. And again, labor is a big part of that in the US. On the US side, it's kind of close to 17% of the total cost of the cell. In China, it's about 11%. So there is a difference there. But again, when you kind of come back to it and you think that the manufacturing process is becoming increasingly automated, actually the impact that labor cost has is going to kind of decrease over time. So there's not a huge difference. Now, if we come to CapEx, there's a big difference there if we look at the kind of the high level numbers. And I just grabbed two examples from the media. So CATL recently built a plant in Guangdong, which was a 35 gigawatt hour plant. And that was roughly 1.7 billion in capex. So on a per gigawatt hour basis, it's about 68 million per gigawatt hour.
That's in US dollars.
That's in US dollars, yeah, exactly. In contrast, kind of the Ford plant that it's building using CATL's technology for manufacturing LFP, so it's a licensing agreement rather than a joint venture. The original kind of capacity that we were looking at there was 35 gigawatt hours as well. And that was at 3.5 billion US dollars. So that works out at 100 billion per gigawatt hour. So you're looking at kind of a 30% difference in a per gigawatt hour cost there. So it is quite significant. But again, when you then think about those plants are going to be operating for kind of 10, 15 years, and well, let's say kind of 15 years for the plant, equipment's probably got a 7-year lifetime. When you start to think about the kind of amortization of that depreciation over the kind of lifetime of the factory and over all of those kind of billions of cells that are going to be produced, it's relatively small. You're looking at a kind of percent difference in the impact on a per kilowatt hour basis at the cell level. So these factors, they make a difference, but nothing that is, let's say, insurmountable.
Okay, so both CapEx and OpEx drive a delta, but it's not huge, and it wouldn't explain the difference in like prices that we see coming out of China versus the West. So if it's not CapEx, it's not OpEx, what is it?
And this is and so this is the interesting thing. I think the point that you made is it's not necessarily the obvious things that you're thinking about. It's more, a lot of it's down to operations. So yield is a big factor here. If you can't get a high yield, then you're wasting a lot of material, you're using all that energy, you're using all that labor, and you're not getting a product at the end of it that you can sell. And this is where kind of China has a huge advantage over the rest of the world. China has been manufacturing batteries since the early 2000s. They've grown at the fastest rate of any other kind of region in the world. And they have a workforce who has been working in those facilities for, going on for kind of more than 15, 20 years at this point. So they have a lot of skilled laborers who understand battery manufacturing and understand, how to use the equipment and how to get those kind of yields up quickly. Whereas if you look at a couple of examples from the West, the most obvious one at the moment is going to be Northvolt. Northvolt started manufacturing cells on its plant around the end of 2022, I believe. So kind of we're coming up to 2 years now. And if the media reports are to be believed, they're still having a huge issue with yields. They can't get their yields up, and that's pushing the price of their cells up dramatically. And I believe it was BMW who kind of cited costs and kind of yield as one of the reasons that it was cancelling one of its initial contracts with Northvolt. So getting that kind of yield up is a key part of it. Having a skilled workforce is essential there. The other part of it, and this is something that I think that the workforce side of things, the West, they will build those skills up over time. There's a lot of kind of programs going on to kind of reskill and upskill the workforce. So we'll get there. But the other advantage that China has is close access to equipment manufacturers. So they have, if there are any issues, if they need to troubleshoot something, if they have any kind of issues with the equipment kind of breaking down or whatever, they can quickly get onto those equipment manufacturers and they can get the engineers in, the technicians in to troubleshoot it and to get that equipment up and operating again. Outside of China, there's only a limited number of companies, or outside of Asia, I should say, there's a limited number of companies that have that capability. And certainly, in the US and in Europe, where a lot of companies are actually using Chinese equipment, you can't get those engineers there that quickly. You've got to get them on the plane, fly them over. That's going to take, it's going to take time, right? And that's going to cost you because you're not going to be able to operate your facility as expected. So I think that, yield kind of an uptime there are two kind of big factors in it.
Yeah, there's an extent to which the yield one, you can spin that as kind of a positive for the West potentially, in the sense that okay, if it's, if the reason China can produce so much cheaper cells is because labor costs are so low, environmental permit regulations are so lax, et cetera, it's difficult to imagine how the West ever solves that problem. On the other hand, if it's basically that China's really good at it, they got their yields up because they have experience and they're very good, that's at least a challenge you can imagine to be surmountable for the West. Now, not easy, obviously. I don't mean to minimize it, but it's at least something that feels like it's in the control of Western battery manufacturers. Maybe a little bit less so the access to equipment manufacturers and so on, but at least the yield one, you can sort of picture somebody could do it better here. Maybe novel technology that allows for higher yield, maybe not, maybe just better operational performance. But, if that drives a big component of the cost delta, obviously it's difficult. Northvolt's struggling with it, as are others, but it seems possible. The other thing we should at least address, right, and the thing that has been, is always sort of thrown out, I think, often without much detail behind it, is this general assumption that, China subsidized the hell out of battery manufacturing, China Inc. And I think that is true to an extent, and you should tell me a little bit about what form those subsidies have taken. Of course, now we in the West are also at least attempting to subsidize the hell out of this stuff, certainly in the US through the IRA, and I think in Europe through a bunch of mechanisms as well. So there's an attempt to sort of replicate that, but it's in a different form. So in your view, what have those subsidies looked like in China, and how big a difference have they made in the cost structure?
Yeah, and subsidies are definitely kind of have had a big impact. And it's interesting in China, it's always difficult to understand, the full extent of what the subsidies look like. But certainly the kind of most straightforward one is going to be kind of low land costs. So you'll often have kind of provinces that will provide land to manufacturers for free to get them to build a plant there and to kind of secure that industry. You've then got the kind of direct, indirect subsidies, if you like. There was a long program of EV subsidies in China where kind of EVs that were using Chinese-produced cells would get a higher subsidy, and the cell manufacturer would get a portion of that as well. So not dissimilar to what we're seeing with the IRA now, in fact. And that was a big part of kind of setting up the Chinese industry and getting Chinese automakers to use Chinese kind of produced cells. So that kind of has played a factor. Those subsidies were phased out, believe earlier this year or earlier in 2023. I can't remember off the top of my head, but we've seen those subsidies, phased out. And now I think more what I'm hearing about is it's the kind of land subsidies. That's a big subsidy that Chinese cell makers are getting today. I'm sure there are kind of tied into that as well, kind of tax breaks as well. Again, similar to what we see in other parts of the world. So it's not that China has a kind of secret subsidy regime that is perhaps kind of better than anyone else in the world. It's that I think that they did it first, and particularly again, kind of in the kind of 2010 period to 2020, that did make a big difference. But I think what a lot of people kind of fail to realize when they're thinking about that is that the kind of bulk of China's manufacturing capacity has been or will be commissioned, in the 4-year period from 2020 to the end of 2024. If we go back to 2020, kind of commissioned capacity in China was about 550 gigawatt hours. By the end of this year, if all the kind of projects that are under construction are completed, you'll be looking at about 4.5 terawatt hours of capacity. So really, 90% of the capacity is being built in this 4-year period at the same time as we're building kind of capacity in Europe and the US. So the subsidies from the last decade, they've helped to build up these big companies that we know, BYD, CATL, Eve Energy, etc. But they're not fundamental in this, in the way that people think they are to the kind of low cost structure that we're seeing in China today.
The other thing that I think plays a role, I know this was true in solar over the years, as like China was ramping up PV manufacturing and Western companies were trying to compete. You'd have these periods, the market's cyclical, and you'd have periods of oversupply and prices would crash, as we are seeing now in battery world. And one of the things that would happen in that crash is that you would see a shakeout in China. A bunch of companies would disappear and fail. But the bigger ones at least could withstand 0 to negative margins for a while. And so on the other side of that, there would still be a few really, really large Chinese PV manufacturers who just had the capacity and the capital and the support to withstand a temporary crash in prices and removal of margin effectively. But Western manufacturers really struggled with that and just didn't have the capacity to weather the storm. And I wonder whether that's sort of what's going to happen here too. Like maybe all those plants that you mentioned in construction to get to 4.5 terawatt hours, they probably won't all get built, right? Not in today's environment. And we probably will see a shakeout in China. But is CATL going anywhere? Probably not, right?
Yeah, I think you're spot on there. That's exactly the kind of environment that we're in at the moment. And again, there are kind of reports coming out of China of just that happening, of manufacturers selling with kind of low to 0 to kind of negative margin in order to maintain market share, in order to kind of keep their plants operational rather than just kind of mothballing them. So it's interesting that we are in that situation. I think we will see a kind of shakeout of probably tier 3 players more than the kind of tier 2 players. I think CATL, as you say, and BYD, they're not going anywhere. I think the tier 2 guys, the Eve Energies, the Goshens, the Lifeon, etc., they're going to kind of stay around. It's some of the kind of smaller players that, as you say, they don't have those longer term contracts. They've perhaps been relying on more of these kind of spot market contracts that we discussed earlier to shift their cells, and they're the ones that are going to suffer the most. They're either going to have to kind of in fact, I have heard of kind of reports of some companies basically kind of selling at the cost of the raw materials, so not even kind of including manufacturing costs in there. So I think it is back to what I mentioned earlier. It's a bloodbath in China at the moment. We are going to see that kind of consolidation of the industry, but the big players, they'll survive. And actually, maybe it's even perhaps a kind of blessing in disguise for the West, because we don't have these big homegrown factories that are operating today and having to compete with those low margins. They're still in construction. And so that could be the kind of silver lining, if you like, for those companies at the moment, is that they're not directly competing today. They're thinking of their costs in the next kind of 2 or 3 years.
All right. So to wrap it up, let's come back around to this key question I mentioned earlier, which is what is the prognosis for Western battery manufacturing? Is there a way for these battery manufacturers in the West who are just starting to scale up right now or starting to construct their projects right now, are they going to be able to weather this storm? And I guess relatedly, because you you were at Bloomberg NEF, now you're on the technology investment side with me. Is novel technology the way out of that trap? In other words, there are lots of kind of what I would call standard, like LFP cell manufacturing facilities planned, or NMC for that matter, for the West. Then you're competing just head to head against the same thing. Can you win by playing a different game and doing something entirely novel? Is that actually something that could work? That was always the premise in solar, for example, and really First Solar proved it to be true, and everyone else proved it to be wrong. So I'm curious if you think batteries are the same or different.
I mean, I feel like there's only one answer I can give here. I've been a technologist, working on battery technology since kind of 2010 or so, and have always been a big believer that the technology will kind of drive the industry forward and help to kind of reduce costs. So I think the answer is yes. You can use technology to kind of save the industry, and differentiate what the West is doing compared to China. I think you're right that if you're just kind of competing on LFP and it's a race to the bottom, then that's when you're going to struggle. And there's already been, I think you can already see that actually some Chinese players think that it would be cheaper to import LFP cells from China, pay kind of any taxes or whatever, and then have them deployed in the US rather than manufacturing them locally. Now, I haven't looked at, I haven't done that analysis myself, so I can't see can't say exactly what the nuances there are. But the fact that some Chinese kind of companies think that it's still cheaper to manufacture in China and export to the rest of the world, that kind of speaks volumes on that side of things. But I think what we see is that there has been a lot of technology development going on in the West. While China has been building up capacity, the West has been advancing on the technology side. And a lot of Chinese companies don't have the IP for that kind of those new technologies outside of China. So this creates a kind of interesting dynamic that we're seeing where Chinese companies want to get out of China because it's a bloodbath. It's difficult to do business and make money there at the moment. They want to sell to the West, but the technologies that are about to be adopted, and going back to silicon as an example here, right, imminently going to be adopted in electric vehicles. A lot of Chinese companies don't have the freedom to kind of operate and sell that material outside of China. And you've got a load of startups in Europe and the US who have the IP, they have the freedom to operate, they have the technology. But actually what they don't have is the kind of cash to build facilities, to scale up, to actually get their product out there. So I think there's a unique opportunity at the moment where you could see kind of Chinese players coming with cash, working with these startups, helping the startup to scale, and building facilities in Europe, in the US, to bring these new technologies online. The startups, or European technology, US technology gets adopted. We see that kind of return on investment. And at the same time, we have the skills from the Chinese players being utilized. We have that knowledge on how to get those high yields. We have the connections to the equipment manufacturers. We have access to those supply chains, which we haven't talked about much, but actually the supply chain development in China is a big part of why they've got low cost as well. And so partnerships with kind of Chinese cell manufacturers, Western technology developers, I think is a big way that would be a kind of almost a win-win situation for everyone, and would see us onshoring battery manufacturing in the US and Europe with a differentiated technology that's not just a race to the bottom on the kind of LFP side of things, but is trying to kind of improve performance. So that's my outlook. Hopefully it's not too naive, and this is something that we see kind of happening in the next couple of years. But certainly we're seeing the kind of the beginnings of that kind of stirring in the industry, and even the kind of Ford CATL licensing deal is almost an example of that, although it's in reverse, right? Ford is putting the cash in to build the plant, and we're taking CATL's technology. But just seeing that we're building those relationships kind of gives me confidence that a lot of the earlier stage companies in Europe and the US will be able to get there. What it doesn't necessarily perhaps solve is for the homegrown cell makers that we have in Europe and the US, the Northvolts, who are struggling kind of on the just the manufacturing side today. And I think that, again, is why taking advantage of the Chinese know-how really kind of rings home for me at the moment as something that we should be exploring, if not taking advantage of.
James, this was a lot of fun. Thanks for the time.
My pleasure. Thanks, Joel.
James Frith is a principal at Volta Energy Technologies. This show is a production of Latitude Media. You can head over to latitudemedia.com for links to today's topics. Latitude is supported by Prelude Ventures. Prelude backs visionaries accelerating climate innovation that will reshape the global economy for the betterment of people and planet. Learn more at preludeventures.com. This episode was produced by Daniel Waldorf, mixing by Roy Campanella and Sean Marquand, theme song by Sean Marquand. I'm Shail Khan, and this is Catalyst.